interface is on port 80 and the raw XML stream is on port 8000. Okay, then I will switch over to Pavel, who will talk about the visualization. Yeah, okay.
Yeah, okay, just a couple of words regarding the visualization you can see downstairs. We choose to set up a virtual observation camera setup. So we have a 3D model of the DCC, which was provided by Martin, who was working on this model for years, I think. And we took the model and exported it in our proprietary XML format for our Y60 engine, and did write this application mostly in JavaScript with a few C++ modules to handle the avatar billboards. So we tested it with up to 1,000 billboards that can move simultaneously in the world, and hopefully this should work. We'll see. Okay, just a couple of words regarding why we did use this engine. First of all, because we know it, and it's an engine that is done to do special applications in a very short time. So actually, it's more a 3D multimedia framework, and I think it took roughly, I would say, the order of 10 to 15 days to put everything together you see down there. Yeah. How does it work? It's quite simple. You've seen the HTTP stream. We just parse the stream, and if we see a new tag there, we create a new avatar. If a known tag is observed with position information, we animate the avatar to move to the observed position. So what you will see down there then is a lot of moving around, because we do randomize the positions within the estimated area. If a tag is not seen for some time, in our case 30 seconds, then we silently remove it. We have a touchscreen interface down there where you can select virtual cameras. I think we have about 30 virtual cameras which look like or act like observation cameras, and we can select one and sweep it and look into all the different rooms, and then all the avatars running around are pickable, so you will be able on the touch screen to pick an avatar, and then it will retrieve the information associated with the tag ID if there is one, and also display the talks you have visited. Okay, so thank you very much, and all you have to do now, if you haven't done it already, buy one or more of these tags. I think it's fun to have more of them, to play with them, create your user ID, and come to visit us on our booth and get your tags associated. Thank you. Is there a mic somewhere here, or if you would come to the front, I give you this mic, and please all. Yeah.
Is it technically possible to include the receive power on the reader side in the data that's sent to the aggregator?
Yes. Technically it's not possible because the data packets are very short, and it won't be possible to get an accurate measurement on the strain effect. Also the chip natively doesn't provide it. It basically gives out the process data on a digital line, and you don't have to access the transmit power. Such chips exist, but they are a lot more expensive, and they only would work if you constantly transmit power. So I think this is not possible with the cheap solutions if you want. If you have, for example, such a Blu-ray device which has at least two input antennas, you can also use beamforming on the data together, and afterwards do a virtual sweep around to get the direction the data comes from. But this is far more expensive and we couldn't afford it. For this, we wanted to keep the reader cost as low as possible. Currently it's around €60 production, but with Q radio it will be several hundred euros.
Das Klimasignal ist scheiße. Fahrstreifen drinnen.
Achso, ich habe auch Videoseite.
Das Video quillt. Was er von seinem Laptop hochschickt, das ist scheiße.
The only frequency range besides of some private attention that is international safe. So basically you can use this device in every country without violating the law. And I think this is very important for open source projects. So people want to just copy it and make it something with local law. The question was how can a wireless LAN and devices cooperate in the same frequency band. Wireless LAN is basically you have only three non-overlapping channels.
Stundentape, oder?
And the hardest channel
Da steht was wegen 45 Minuten.
Germany is channel 11.
Was ist mit dieser Anzeige zeigt?
Ja, aber die läuft hier runter.
Die habe ich jetzt nicht verändern sehen.
Allowed ISM-band, which is allowed up to 2483 megahertz. So basically configured the text to 2481 megahertz, and so we are as far as possible from the wireless LAN networks. And obviously we won't disturb them, but they could disturb us because we only transmitting at 1 milliwatt, and they transmitted much higher powers.
How does the position of the tag room influence the signals range?
I got the last
How does the position of the tag influence the power of the signal? For example, if you hold it horizontal or vertical?
So basically, the room orientation, the changes are practically not that big. So it's merely a spherical radiation pattern. But it definitely matters where you put the tape. For example, you put it on your chest, then it will be visible from the reader. Here's the reader. But if you put it, for example, on your trousers, then it will be well hidden and maybe the reader won't see you at all. So, but the orientation of the tape itself doesn't matter much. It's only, say, makes a difference of 20% range or so.
Can you consider including voice sensors to detect whether
we have a version with a 3D accelerator, and the data is only also much less power. It draws much less power because you only have to send data if there is moving. But the cheapest 3D accelerators we found were in the €5 range, and this would increase the tech cost to 15 euros, and we couldn't afford this at this time. But the design is already there and it's working, and there is already a commercial project behind it where you get real-time presentations on how you can learn the tech, and you can control things with motion and explain it. You have the gesture input, so you can make gestures with the tech, and then you could recognize that you can make actions about the gestures.
Auge vor dem Infosender bist du gemacht.
This has been already done. The basic approach is that, again, use a real radio device. It can pick up the HF data that is transmitted by the mobile device, and the problem is that it's basically encrypted, so usually you think there is no possibility to track single users. But they have found a possibility, and it's very sneaky, and I like it very much. They use the temporary ID that is unencrypted, that is assigned by the base station, and throughout the whole range of the base station, for the GSM base station, you have the same ID. So inside the transmitted packets, the ID is always inside, and you have these new radio devices around. You get from the short bursts, you get the actual transmit strength, and by decoding the packets, you get the ID, and this makes it possible to narrow down the position of the person with a mobile phone to a few meters. But again, this was too expensive for the Congress because we need at least 2 or 3, say at least 2 radios and network interface and a computer that is powerful enough to process this huge amount of data. I don't know if anyone knows about the radio and explain data. Any more questions about the XML and web visualization?
My question was more about the tags. The block diagram shows they can receive as well as transmit. You can't really use that for anything.
We were very afraid of meshing protocols because we had no idea how it would scale, and there was no possibility to try it out. This is the first attempt to have a huge number of tags and we test it, and we will do a good job in the next hours and days. But I think meshing won't be possible at this scale for the first test. But technically it's possible, and therefore we can do this watch crystal, so we can create this time slot based on convolution, and I think with this it's reasonable to create such meshing protocols. And what would be very interesting in our view is, for example, if you capture the low-level signals around you, you can remember it in your tag, and every time you pass the reader, you can send it to the server. You can flush your cache. So it can, for example, find out which person usually sticking together, even if in this area is no reader at all. So there are very nice possibilities, but it was too dangerous in our view to create such a complex protocol without the possibility to try on a larger scale. But maybe next Congress we use the same tags, and it can easily be reprogrammed plenty of times, and we will actually need this meshing protocol. But you are free to help us, and we appreciate the help and your ideas about that. Any more questions?
Could you talk a little bit about how you're planning to, after the event, sort of retrospectively improve the data? Are you expecting people to contribute, say, well, actually, I was in this room at this time?
No, definitely. The readers are at least one reader in a room, so we can get an idea which room was highest probability. Because we have our tags, so we can verify it.